Hello everyone. In this video, we discuss some problems from topic line and length. Very first problem, find the shortest distance between the lines r bar is equal to 4i minus j plus lambda into I plus 2j minus 3k and r bar is equal to I minus j plus 2k plus mu into I plus 4j minus 5k. Now, first we see formula list for lines. See, first equation is about line passing through a bar and parallel to vector b bar. Second equation is about line passing through a bar and b bar. This is second equation. Third is about Cartesian equation of line passing through point A x1 y1 z1 and having direction ratios A, B and C. This is formula for that. Next line is distance of a point from line. Next one is for shortest distance between these two lines. Next is about condition for intersection of two lines. That is, these two lines intersect each other if and only this condition is satisfied. Next is lines given in this format. X minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1 and x minus x2 upon a2 y minus y2 upon b2 is equal to z minus z2 upon c2 intersect each other if and only if this determinant is equal to 0. In our problem, we are asked to calculate shortest distance between lines. So we are interested in this formula. If lines are represented by r bar is equal to a1 bar plus lambda 1 b1 and r bar is equal to a2 bar plus lambda 2 b2 bar, then shortest distance between them is given by this formula. D is equal to modulus of a2 bar minus a1 bar dot b1 bar cross b2 bar divided by modulus of b1 bar cross b2 bar. This is required formula. Now we compare these given equations of lines with standard equations. So we get values of a1, b1, a2, b2. This is a1, this is b1, this is a2, this is b2. Therefore, आता a1, a2, b1, b2 या व्हॅल्यू यूज करून आपल्याला फॉर्म्युलामध्ये ज्या व्हॅल्यू लागणार आहेत त्या कॅल्क्युलेट करूया. Therefore, a2 bar minus a1 bar is equal to I minus j plus 2k minus 4I minus j, which is equal to minus 3I, which is equal to minus 3I plus 2k. Now we calculate b1 bar cross b2 bar. Its value is determinant ijk. Here write down coefficients of b1 in second row 1, 2, minus 3 and coefficients of ijk in b2 1, 4, minus 5 and then solve this determinant. This determinant is equal to 2i plus 2j plus 2k. Therefore, b1 bar cross b2 bar is equal to square root of 2 square plus 2 square plus 2 square is equal to root 12. equal to 4 square root of 4 into 3, which is equal to 2 root 3. Now we calculate a2 bar minus a1 bar dot b1 bar cross b2 bar. Substituting values, a2 bar minus a1 bar is minus 3i plus 2k dot b1 bar cross b2 bar is 2i plus 2j plus 2k, which is equal to minus 3 into 2 is minus 6 plus 0 into 2 is 0 plus 2 into 2 is 4, which is equal to minus 2. Now substitute calculated values in formula. We get modulus of minus 2 divided by 2 root 3, which is equal to modulus of minus 1 upon root 3, which is equal to 1 upon root 3. Therefore, value of d is 1 upon root 3. Therefore, required shortest distance between the given lines is 1 upon root 3 units. This problem is over. Now we turn towards next problem. Now we discuss next problem, problem number 2. Cartesian equation of a line is 3x plus 1 is equal to 6y minus 2 plus 1 minus z. Then find vector equation of the line. Now solution. By given Cartesian equation of a line is 3x plus 1 is equal to 6y minus 2 is equal to 1 minus z. Next step, make coefficient of x, y and z is 1. See, in this term coefficient of x is 3, in this term coefficient of y is 6, in this term coefficient of z is minus 1. So if we divide this term by 3, we get coefficient of x by 1. This term by 6, we get coefficient of y as 1. And if we divide this term by minus 1, coefficient of z will be 1. Therefore, write 3x plus 1 divided by 3. As we are dividing numerator by 3, divide denominator also by 3. So denominator term is 1 by 3. In second term, we are dividing numerator by 6. So 6y minus 2 divided by 6 divided by 1 by 6 is equal to 1 minus z divided by minus 1 divided by 1 upon minus 1. Therefore, x plus 1 upon 3 by 1 upon 3 is equal to y minus 2 upon 6 divided by 1 upon 6 which is equal to z minus 1 divided by minus 1. Now, we interpret from this equation, this line passes through points this line is passing through points A in bracket. See how we are writing these points. X minus, here no minus sign is present, so here we write minus 1 upon 3. Here it is 2 upon 6 and here it is 1. That is A minus 1 upon 3, 1 upon 3, 1. This 2 upon 6 can be written as 1 upon 3. So we have written here, and having direction ratios denominators are direction ratios. So direction ratios are 1 upon 3, 1 upon 6 and minus 1. Let A bar be the position vector of point A with respect to origin and B bar is vector parallel to given line. Then A bar is minus 1 upon 3i plus 1 upon 3j plus k, and B bar is vector formed by these direction ratios, that is 1 upon 3i plus 1 upon 6j minus k. Now, vector equation of a line passing through A bar passing through point A whose position vector is A bar and parallel to B bar is given by R bar is equal to A bar plus lambda B bar. Now substitute values of A bar and B bar. So we get R bar is equal to minus 1 upon 3i plus 1 upon 3j plus k plus lambda in bracket 1 upon 3i plus 1 upon 6j minus k. Therefore, vector equation line is R bar is equal to minus 1 upon 3i plus 1 upon 3j plus k plus lambda into 1 upon 3i plus 1 upon 6j minus k. So problem is over. Find the angle between the planes R bar dot I plus j plus 2k is equal to 13 and R bar dot 2i minus j plus k is equal to 31. Now solution. First we discuss formula for it. See, this is page from your textbook only. This is formula for angle between the planes. R bar dot n1 bar is equal to d1 and R bar dot n2 bar is equal to d2. Then angle between them is given by cos theta is equal to n1 bar dot n2 bar divided by magnitude of n1 bar into magnitude of n2 bar and their modulus. So we write this formula. This is formula. Now by comparing given equations of plane R, therefore here n1 bar is equal to I plus j plus 2k and n2 bar is equal to 2i minus j plus k. Therefore, n1 bar dot n2 bar is equal to I plus j plus 2k dot 2i minus j plus k, which is equal to 1 into 2 is 2 plus 1 into minus 1 is minus 1 plus 2 into 1 is 2, which is equal to, therefore n1 bar dot n2 bar is equal to 3. Now it's equal to square root of 1 square plus 1 square plus 2 square, which is equal to square root of 6. 2 bar is equal to square root of 2 square plus 1 square plus 1 square is equal to root 6. Substituting in formula, we get cos theta is equal to modulus of, in 1 bar dot in 2 bar is equal to 3 divided by magnitude of in 1 is root 6 into magnitude of in 2 is root 6, which is equal to modulus of 3 upon 6, which is equal to 1 upon 2. Therefore, we get cos theta is equal to 1 upon 2. We know that cos of 60 degree is equal to 1 upon 2. Therefore, cos theta is equal to cos of 60 degree. Therefore, theta is equal to 60 degree. Therefore, angle between given two planes is 60 degree. Hence the solution.